In this video, I'm going to be explaining the topic of differential leveling. Before that, I'll give a brief introduction on what leveling is. Leveling is a branch of surveying, the object of which is to find the elevations of given points with respect to a given or assumed datum and to establish points at a given or assumed datum. The first operation is required to enable the works to be designed, while the second operation is required in the setting out of all kinds of engineering works. Leveling deals with measurements in a vertical plane. Level surface. A level surface is defined as a curved surface which at each point is perpendicular to the direction of gravity at that point. The surface of a still water is a truly level surface. Any surface parallel to the mean spheroidal surface of the earth is therefore a level surface. Level line. A level line is a line lying in a level surface. It is therefore normal to the plumb line at all points. Horizontal plane through a point is a plane tangential to the level surface at that point. It is therefore perpendicular to the plumb line through that point. Horizontal line is a straight line tangential to the level line at a point. It is also perpendicular to the plumb line. Vertical line, it is a line normal to the level line at a point. It is commonly considered to be the line defined by a plumb line. Datum is any surface to which elevation are referred. The mean sea level affords a convenient datum world over, and elevations are commonly given as so much above or below sea level. It is often more convenient, however, to assume some other datum, especially if only the relative elevation of points are required. Elevation. The elevation of a point on or near the surface of the earth is its vertical distance above or below an arbitrarily assumed level surface or datum. The difference in elevation between 2 points is the vertical distance between the two level surface in which the 2 points lie. Vertical angle is an angle between two intersecting lines in a vertical plane. Generally, one of these lines is horizontal. Mean sea level, it is the average height of the sea for all stages of the tides. At any particular place, it is derived by averaging the hourly tide heights over a long period of 19 years. Benchmark. It is a relatively permanent point of reference whose elevation with respect to some assumed datum is known. It is used either as a strong starting point for leveling or as a point upon which to close as a check. Now, differential leveling. Backside is a shot taken on a point of known elevation. Benchmark is a relatively permanent point of known elevation. Height of instrument is the elevation of line plane of sight. Foresight is the shot taken at the point of unknown elevation. Turning point, temporary, unidentifiable point of fixed elevation. Differential surveying is used to determine the difference in elevation between two or more points. It is commonly used to establish the elevation of a benchmark reference to an existing benchmark. It is also useful for the comparing the elevation of several points or objects. Differential leveling, a major example of comparing the elevation of multiple points is setting the top of the forms before placing concrete. In common practice, a backside would be recorded from the benchmark and the target would be set for the desired elevation of the forms. The ranging rods were then placed at several points along the forms to determine if they were at current height. Establishing a benchmark. Another use of differential leveling is establishing the elevation of a benchmark. When the existing benchmark and the location of the new benchmark can be seen from one instrument position, the procedure is very simple. The instrument is set up halfway between the points and leveled. A rod reading is taken on the existing benchmark. This is called a backside. The backside reading is added to the elevation of the benchmark to establish the instrument height. This is direct differential leveling. The progresses from known to unknown. Known elevation plus backside is equal to height of instrument. Height of instrument minus foresight is equal to elevation known. Level head moves ahead. Here we see the tripod stand. Ahead of the tripod stand is the backside and behind it is the foresight. Again, here we see three readings taken. The first is the tripod stand. In front is the benchmark, behind the backside. and again backside, and behind is the foreside, and the backside and the foreside, and so it goes on. A backside is a rod reading taken on a point of known or assumed elevation. It is the vertical distance between the line of sight through the instrument and the point of known or assumed elevation on which the rod is set. When a Philadelphia or similar type rod is used, the vertical measurement will be in units of decimal feet. The backside reading is used to establish height of the instrument. A backside will always be taken on a benchmark or a turning point. In this example, the benchmark elevation is 850.45 feet and the backside is 3.56 feet as shown in the diagram. Through this, we can find the height of instrument. It is given by the sum of benchmark and the backside, which in this case is 854.03 feet. The instrument is rotated until it is aligned with the second benchmark. A rod reading is recorded for the second benchmark. In this example, the foresight is 5.21 feet. The rod reading is subtracted from the height of the instrument to find the elevation of the second benchmark. The elevation is HI minus FS, 854.03 feet minus 5.21 feet, which is equal to 848.82 feet. Here the BM1 is 1.65 feet higher than BM2. When both benchmarks cannot be reached from one instrument position, turning points are used. Because a turning point is a temporary benchmark, it must be a stable structure. A backside is taken on BM1. In this diagram, the 4.31 is added to the elevation of the benchmark to find the height of the instrument, which totals to 104.31. A turning point is established and the foresight is recorded 4.92. The foresight is subtracted from the height of instrument to determine the elevation of the turning point, which is 99.39. Then the instrument is moved to a point between the turning point and the next station. In this example, the next station is BM2. The foresight on BM2, 2.35, is subtracted from the instrument height to determine the elevation of BM2, which is 101.08. Tables are an excellent way of organizing numbers. Surveyors have developed a standard table for differential leveling. Here we see the table. There are 5 columns. STA stands for station identification. Here there are 3 stations, BM1, TP, and BM2. Backside, HI is instrument height, FS is foresight, and ELEV is elevation. In this table, for the example, is backside is given 4.31 and 4.22, HI is given, FS is given, and LF is given. When you subtract 101.08 minus 100, we get 1.08. So you find that BM2 is 1.08 feet higher than BM1. Assuming no errors occur during the survey, BM2 is 1.08 feet higher than BM1. This is not a good assumption. Differential leveling uses 3 checks for errors. Mistakes or errors. Mistakes can happen while if you misread rod, poor rod extension, mud, snow under the roof, reading wrong crosshair. Errors are rod might not be vertical, wave rod, settling of rod, BS and FS not equal, instrument not level, parallax and personal errors. Personal errors include heat waves or too long or short. Leveling procedures, anchor legs firmly, sloping terrain, 2 legs on downhill side, BS and FS the same distance, wave the rod, hand voice signals, race for red, high rod, turning point, race lower target, plumb rod. Thank you.